Thanks everyone for coming and hearing me talk. When I started doing this research, I was working on the red team at Zoom. And at that point, I had been working in pretty much an all macOS endpoint environment for a few years. So it's kind of what I was familiar with. And all the red team engagements we got on, by the time we got to persistence, we'd always use the same thing. We'd always use launch items persistence, which is what this talk is about. The reason being, well, it's easy to do, and it's what all the adversaries are doing, and all the Mac malware does, pretty much. So why not just do what's easy to do? So I started doing research to figure out, how can we stop this from being so easy for the adversaries and for the red team, so that we can do some more creative persistence methods that are out there, because there's many out there, but like I said, the adversary is not going to use them when they can just use this one. So this is my talk, launch items, the most common Mac OS persistence techniques. Who am I? I'm Antonio Piazza. I'm currently on NVIDIA's threat operation team, and I'm the purple team lead there. I'm also in my final course in the SANS Masters of Information Security program. I was on the Zoom red team. I was on Cleveland Clinic red team, Box red team, and did a red team for defense contracting for many years before all that. All right, so the persistence tactic, if you're familiar with MITRE ATT&CK framework, it's TA0003, that's the tactic number. On the MITRE ATT&CK matrix, the tactics go horizontally across the top, and then the techniques fall underneath. So once malware has infected a system, more often than not, its next objective is to persist. Persistence is the means by which malware ensures it will automatically be re-executed or executed by the operating system at system startup or user re-login or login. So the vast majority of Mac malware attempts to gain persistence, otherwise the system reboot would essentially disinfect the system. However, two notable examples of malware that generally does not persist includes ransomware, because once ransomware has encrypted user files, there's no need for it to hang around. Thus, that malware will rarely persist. The other one is in-memory malware. Sophisticated attackers may leverage memory-only payloads that by design will not survive a system reboot. The appeal, an incredibly high level of stealth. So malware may also avoid persisting if it determines that a system is not of interest. Perhaps a detect security tool is running that would detect a persistence attempt or other actions taken by the malware. So techniques, this underneath the persistence tactic, you got a variety of different techniques, and the ones we're talking about here are the launch items, agents, and daemons. And the tactic number for MITRE is T1543, create or modify system processes, and then you got these sub-techniques, .001 launch agent, .004 launch daemon. The vast majority of Mac malware leverages launch agents, launch daemons as a means to gain persistence. In fact, according to Objective-C's, the Mac Malware 2019 report, every piece of analyzed macOS malware from 2019 that persisted did so as a launch item. So just to give you an idea how common this persistence method is. Launch items are the Apple recommended way to persist non-application binaries, so software updaters and background processes. So now you can see why this is so easy for an adversary to pull off or malware to pull off. This is actually how Apple tells you to do your persistent mechanisms when you're developing. So it's kind of normal for these things to happen on a Mac system. So as noted, launch items include both launch agent and both launch daemons, and they're launched by launch D. /sbin launch D is where you'll find the launch D daemon. Why is this not switching? Sorry. So to persist as a launch agent, the malware can create a property list or plist in the launch agents directory. To persist as a launch daemon, it'll create a property list or plist in the launch daemons directory. Apple's launch agents live in the /system library launch agents directory, and Apple's launch daemons live in the /system library launch daemons directory. Since the introduction of SIP, System Integrity Protection, in OS 10.11 El Capitan, these directories, these system launch items directories, are now protected. Therefore, malware cannot modify them. So you can't create a system launch item. As such, malware is now constrained to creating launch items in the /library, so the root library directory or the user library directories. So I just kind of notated the user with the little tilde symbol there. And then, of course, the slash would be your root. So let's talk a little bit about property lists. They're super important. It's a plist. It can be an XML, JSON, and rare cases, a binary document. And it contains key value pairs. Theseplists are ubiquitous in macOS. They're all over the place. And it's sort of like the equivalent to the Windows registry. This kind of has these, again, key value pairs. To view the contents of a property list in human readable format, you can use either the plutil command, the plutil tac p, and then the path to the plist, or the defaults read path to the plist. You can use cat, but if it's one of those binaries, then you'll have a hard time reading it. So those other two tools are great. And it's from kind of Apple's definition here. They say macOS allows various interchangeable representations for plists, including XML, JSON, and binary. The former have the advantage of being human readable, while the latter offers a more efficient representation on disk, as well as fast serialization, deserialization. So if you're curious why there are some plists in binary format, that's Apple's reasoning. Okay, so this is a launch item plist. This would be a plist that would use to create a persistence or execute something persistently on macOS. So a launch items property list file describes the launch item to launchd, which is consumer of the plist. In terms of persistence, the most pertinent key value pairs are, you can see the key program arguments, and then similarly, I'll talk about them in a minute, there's the program key. So program arguments and program has to be one or the other, and I'll explain the difference. And then the value contains the path, and optionally the arguments of the launch item script or binary. So that you got your program arguments or program key, and then under the array you have the string values that are going to be the path to your persistence, and then another string value for an argument, and you can continue to have more string arguments underneath that. The run at load key you see there, and then you see the value true. So the value is a Boolean that is set, if set to true, instructs macOS, specifically launchd, to automatically launch the launch item. As the run at load key is set to true, the malware will be persistently restarted by macOS anytime the system is rebooted and the user relogs in. So that's specifically what that does, is launches this every time you start up macOS and log in. The key is used to start the job as soon as it has been loaded. For daemons, this means execution at boot time. And for agents, this means execution at login. And that's your difference between the daemon. You got a launch daemon's going to launch at boot, and a launch agent's going to launch at login. Other notable plist keys are the label. You can see up there. That key is required for every job definition, and it identifies the job and has to be a unique for the launchd instance. Theoretically, it can, it's possible for an agent to have the same label as a daemon, as daemons are loaded by the root launchd, and whereas agents are loaded by the user launchd, but it's not recommended. And then you can see like the convention of the label. Job names are written in reverse domain notation, so you could be like com.redteam.evil, and for private agents, the domain local is a good choice, so local.cleanup. And on here, you can see I have com.example.plist. There we go. Sorry. And then so we were just showed the example of the key program arguments, and this one is the program key. The plist will use the program key when the command contains no arguments. So just specify the complete path to your executable. So that's really the main difference. When you saw the program arguments key, it was going to have the path, and then the next string would be an argument, and then you can put as many arguments and strings below that as you needed. The program key has no arguments. The keep alive key, you'll see sometimes, and that's launchd will make sure that the job is running no matter what, if set to true. This is the most basic setting. A value of true, run the job as soon as the job definition is loaded and restart it, should it ever go down. So if you try to kill a process that one of these launch agents or launch daemons is spinning up, it'll just restart it. They're kind of playing whack-a-mole. All right, so mitigation. This is kind of where my research it was pointing to. How do we stop malware from being able to install launch agents and launch daemons into our system? So BlockBlock is a free and open source tool from Objective-C. Monitors common persistence locations, so your launch items, folders, your launch daemons, directories, and it alerts whenever a persistent component is added. In this example, BlockBlock alerted when I attempted to copy local.test.persist.plist to the user's launch agents directory, and the persistence job launches the calculator app. You can set rules in BlockBlock to not only alert, but also block these persistence installations if you want it to. And this tool is really great. The only problem is that it's not really scalable to the enterprise. You can have this on your home Mac, and anytime it'll pop up anytime something tries to put something in one of your launch items directory. You can scrutinize it and make sure you really want that to be added. But you really can't do this if you're in a corporate environment, with a ton of endpoints. It's just it doesn't all kind of come together and go up to one SIM. So what is our mitigation option at scale? And again, this is where my research comes into play. So I found that you can actually lock root level launch items directories, so the /library/launch agents or launch daemons, using an MDM solution with scripting capabilities like Jamf Pro or Kanji or others. Malware, even if running as root, cannot install a launch item because the folder is locked. The malware must be sophisticated enough to recognize that the directory is locked, unlock it as root, and then install the launch item. And that behavior is not found in the wild. I've never seen malware at all that's done this yet. So how do we do this? How do we lock these directories? So all of the files in a macOS system have what is called a uchange flag, or UCHG flag, representing the immutable bit. So literally the file is not subject to change. This flag can only be changed by the file's owner or the super user. And you can use the ls ~O flag to see the uchange flag. You can see if it's set or not. I know that's probably really hard to read up there, but that's doing ls with a ~O, and you see the little blue thing around UCHG. You can change the flag using the file information UI. As you can see over here, there's like a I circled in red, there's a lock with a little checkbox. If you check that box, it'll actually lock that folder down. And you can open up that information UI by using command, or highlight the file or folder and use command and I. So this doesn't really help us though for scripting at scale. Again, this is something good you can do on your home Mac, but you really can't do that across an enterprise. So I also found that there's something called the change flags utility, and this is a default utility present on macOS, whose purpose is to strictly change these file flags. And you can add the immutable flag using the uChange option. So just use CHG or remove it using the no uChange option. So NO UCHG. And again, only the owner of the super user, only the owner of the directory or the super user can change this flag. So this is kind of a visual example showing the file information UI for both the root launch agents directory and the user launch agent directory. We're looking at this file information as my user, and as we can see, the root launch agents directory, the checkbox is grayed out. I can't change it because I'm not root, but I can change the user folder. You can see is not grayed out. Oops. All right, so applications only need to add a plist to the root launch items directory when they are being installed. This process should be controlled by IT using an MDM solution like Jamf Pro or Kanji or some type of controlled software installation process. So it can deliver a system to the user with IT can deliver a system to the user with the launch items directory already locked, run a script to unlock it when IT wants to install applications, and then run a script to lock it again when the installation is complete. So what about when an application needs to make a change to a plist? And this is really common. We don't want to break the application's ability to do what it needs to do to update these plists, right? So I tested this, and as it turns out, the lock does not prohibit writing to files in the locked directory. It only stops file creation, adding and removing files from that directory. I wasn't sure why this was a thing, so I submitted it to Apple as a bug just to make sure, and they came back and said, yeah, that's actually what we want. So immutable does not really mean immutable in this situation. I have a video real quick. Hopefully it's visible to demonstrate kind of what I found here. Let's see if it's going. There we go. Okay, so I'm coming down here and I'm copying this file and I'm going to show, trying to paste it in there. That was unlocked. Now I locked the directory. And I try to remove, and I get this, I'm not permitted. So I tried to delete that file after I locked it, and I'm not permitted. So this, I'm trying to actually update the value in the plist. It's really hard to see for you guys, and I apologize, but it just shows that I was able to actually update a value in the plist while it was locked. Okay, so we talked about what we can do with the root launch items directory. What about the user launch item directory? So your user launch agents directories. They're not really needed in an enterprise environment when software installation is controlled. So an idea that I had, and this is just kind of off the cuff, I really didn't have time to thoroughly test it out or anything, but it's something maybe you can try out. So IT uses MDM to create an unprivileged user for each system. Unprivileged, so there's no privilege escalation possibilities for this account. This unprivileged user created can kind of act as like a honeypot or a honey account, right? Nobody should be trying to log in with that, so that's kind of a detection thing that you can have. IT can then change the ownership of user launch items and launch directories to the honey user account. So now a normal user does not actually own that directory. So again, they can't unlock or lock it because they're not root or the owner of that directory. So then IT can lock the directories. Now the normal user does not own the directories and cannot unlock it. So this is kind of the recap of this mitigation. Just go through everything I was just talking about. So you can lock the root level launch items directory using an MDM solution with scripting. Use the root account. Unlock only when installing approved software. Relock after the install. And then for the user launch items directories, change the owner of the launch items directories to the honey user account and lock user level launch items directories.
Yes.
Before I go on to this, I do want to say I went through and did all this research, and I was working with Matt Venue over at Jamf. We were pretty excited about this. He was doing all the steps that I had figured out with Jamf, and then a couple weeks later, he sends me a message, and he's like, "Man, I have to like abort this research because Jamf actually." Remember how I was talking about you can update the plist in a locked folder, but you can't add or remove files. Well, Jamf doesn't actually update the plist. They actually delete the plist and add a new one anytime they want to do updates. So they're like, yeah, we can't help you with this anymore. So kind of my research was kind of ended there, at least for them. They said that that's the way they do it. Instead of updating their plist, they delete the old one, or they create a temporary one. Delete the old one and then change the name of that one to the new plist. So I don't know if there's any other MDM solutions out there that actually just update their plist. Maybe they'll start doing that, have this work out. So what do we do? It'd be nice to mitigate, but detection is a must, right? So look into ways to detect this. So if we look at like MITRE ATT&CK's data source, DS0022, which is file creation and file modification. That seems to be the best way to detect this if we're seeing these plist files being created. So you watch for file creation and modification within the launch items directories, and then filter against like an allow list. So if your organization really controls the software that's installed on your Mac endpoints, they can see, well, this is not an approved launch item and block the installation. These are a couple example custom indicators of attack, IOAs, that I wrote with CrowdStrike Falcon query language. So just for example, you could add these and it should, they're probably going to be noisy unless you have an allow list. So if you just threw these queries up there, you're going to get a ton of alerts because stuff's always trying to write to the launch agents and launch items directory because again, that's how Mac tells you to, developers to persist their software. So you're really going to need some sort of SIM to, where you can write like an allow list to filter all this stuff out for you. So there is, for threat hunting, you have Knock Knock, which is another Objective-C tool. And it'll uncover persistently installed software in order to generically reveal malware. This is, again, a really great tool for your personal use. So on your home Mac, you just run it. It'll scan it. It'll say, hey, you have all of these different persistent items on your system, and you can scrutinize them. You can look at the signatures on them, make sure they're from legit developers. So this doesn't, again, it's another tool that doesn't really work at scale. So basically, you can just imitate what this does in your in your infrastructure, right? So you can, all it's doing is it's listing all the plists in the launch item directories and looking at the program and that program arguments key that we're talking about in the plist, and it determines what application is installed with persistence. So you can, build some sort of threat hunt script to go look for all the plists and those directories, look at those program and program arguments keys, and then look at that path to the file that it's actually, or the application that it's actually launching. So then the next step, you could actually use look at the code signing information for the application that path points to, right? And you can go, well, that's a developer that we trust, and that's not. What is that? Scrutinize it a little more if it's not. And if it's unsigned and you don't expect that in your environment, definitely scrutinize that. And you can also filter the list against an allow list again. That seems to be the best way that I can come up with hunting for these. You can also, script out something to list all of these and then stack them, unique, and sort them, and take a look at like the least found executables in your environment, or the most found, however you want to stack those. Yeah, so that's all I got. And again, it sucks that Jamf kind of ruined my research by telling me that the way that their stuff works. But hopefully this gives you all some ideas to start thinking of different ways that you can defeat this in your own environments as well. Any questions from any? Yeah.
So with the plist being writable, being updatable, are there any sort of checks or signing or anything like that to make sure that the plist only contains code that's valid or signed or anything like that? Or could a malicious piece of software update a plist and launch itself from a different directory?
Yeah. So the question is basically, hopefully I get it right, is there anything that will stop, I guess, the modification of a plist to make sure that everything in it is legit? I don't know of anything out there that does that. There might be some EDR stuff that does it. I doubt it. Mac EDR stuff, it doesn't seem to be that great in my experience. And yeah, and that's kind of one question I get earlier on. I said, malware might be able to actually change a plist if it has root. So people are like, well, if they can do that, then your mitigation really doesn't work. It's true, but you have to get it to execute as root. So I don't know of anything offhand that would stop that. It's not, and the plists are just XML basically, or JSON, so it's not it's an application that has a signature. It just points to an application that has a signature. So really, that's probably where you want to focus on, is where that program argument or the program arguments, the program key is pointing to. I'm pretty sure. I can't think of anything out there that really focuses on plist being changed or manipulated, or stopping that from happening. Any other?
I still kind of see this as giving your users admin, which allows them to create or edit plist files in the launch agent /Daemons under /library is still kind of a problem. I mean, the user itself still has a launch agent folder specifically for the user, and then Apple has their separate text, like you kind of mentioned, under /system.
Yeah.
But I guess the thing is that this is still, don't allow your users to have admin or to run as admin. Use like Jamf to allow them to go to a software library and download the software they need. And I understand that doesn't work in all cases, but if, kind of like the question he posed is, what happens when malware overwrites the existing P list, and you still protect that directory, at that point, the malware can run, but the threat actor actually has to know what the name of the P list is. And they can pick a common like com.microsoft.io, something like that. But at the next reboot, the next time the application launches, it should overwrite or rewrite that P list file. It should, in theory, disable the malware that would be running. It would be only running in the context of the user and not as privileged user, as a privileged, not system account, but as an elevated admin.
Right. Yeah, no, I totally agree. And I probably should have said that from the beginning. Like, I was looking at this from a perspective of an enterprise environment that actually does not allow the user admin. And unfortunately, it's common for enterprise environments to actually let Mac users have admin on their system. So that would be something I'd totally make sure your user doesn't have admin rights, can't give themselves sudo rights, and then lock it down from there. And like I said before, like if you were to create, and again, this was just spitballing, and I don't know how it would work in reality, but like if you were to create that honeypot user and then give that user the ownership of the normal user's launch items folder, now that normal user actually does not have if you lock it down, cannot unlock that directory. Now the admin would have to log into that honey user account, unlock it. And really, again, I did a lot of looking at like, okay, what applications actually require a user launch agents, launch Daemons, or launch agents directory, and there's really not a lot, like in an enterprise environment, especially if you're really controlling the software that's getting, a lot of that stuff's gonna go in your root launch items or launch Daemons directory. So you really can stop the user from doing anything with those launch item or launch agents directories if you wanted to.
And just kind of spitballing off of that, just something that kind of popped into my mind while you're talking about that. If the P lists can pass arguments to the application as it's launching it, if you had something, say like a Microsoft Excel or Word vulnerability or something, could it tell it to start the application and then go ahead and open a file that has like a macro or something of that sort in it that could could basically open up more vulnerabilities in the system?
Yeah, I'm not really sure. That'd be something I'd have to sit down and really think about. But yeah. Sorry. Anyone else? All right. Well, thanks a lot. If you have more questions, I'll be getting a beer here. So thanks a lot for coming. Appreciate it.